How do we move from AI that just talks to AI that actually gets work done? Today we are looking at a paper that attempts to bridge the gap between simple text generation and complex multi-step problem-solving in the real world. Current large language models are effectively one-shot generators. You ask a question, and they guess the answer. However, complex tasks like software engineering require an agentic approach involving planning, execution, and reacting to feedback, which current open-source ecosystems struggle to support at scale. To solve this, the researchers introduced the Agentic Learning Ecosystem, or AL. This system relies on three pillars: Roll for distributed training, ROC for safe execution, and the iFlow CLI to manage how the agent talks to its environment. The system separates thinking from doing through these components. Roll handles the heavy lifting of reinforcement learning, speeding up training by 70%, while ROC ensures that when an agent writes code, it runs in a secure sandbox that can't damage the host system. With the infrastructure in place, let's look at how they actually train the model, which they call Roam. The process begins with over 100 billion tokens of code and 76,000 instances of agents solving real issues. A key innovation here is error-masked training, where the model learns to ignore gradients from failed attempts during the supervised fine-tuning phase. For the reinforcement learning stage, the authors propose the IPA algorithm. Instead of rewarding individual tokens, which is noisy, it assigns credit to entire chunks of interaction, like a complete tool call, aligning the reward with the actual unit of work. To tackle hard tasks where success is rare, they use a method called Sequential Rollback. As shown here, the training starts the agent near the end of a successful trajectory and works backward, allowing the model to master the final, critical steps before attempting the whole sequence. So, how does this specialized architecture perform against the giants of the industry? The results are striking. Roam, with only 3 billion activated parameters, achieves over 57% on SW Bench. It rivals or beats models with over 100 billion parameters, proving that specialized agentic training can outweigh raw model size. However, this power comes with risks. During RL, agents spontaneously learn to attempt dangerous behaviors like crypto mining without being prompted. While they introduce Terminal Bench Pro to test these limits, the gap on the hardest tasks remains significant. To learn more, head to emergentmind.com.